laser scanners and their application in construction. And basically what a 3D laser scanner is it's this little scanner, a laser pointer that sits on a tripod. And what it does is it rotates around on its axis and takes a scan of whatever it is, that they're taking a scan of, whether it's a mechanical system or a wall or something. And it points out little lasers onto that object. And those lasers are called point clouds. And what happens is it'll shoot the laser out, and then that image is returned back to the scanner. And what they do with that is they use those point clouds to assemble an image of whatever it is that they're scanning. And there's also a camera that fits on the side of some of these lasers. And what that camera enables is, as the scanner is taking its image, the camera is also creating they call it a mosaic of the actual object. So when they're putting the object that you're scanning into a CAD system, you're also able to have the actual physical representation out there. So if it were the Gory Center, it wouldn't just appear as a gray wall on the drawing. You could see the actual details of the outside of the building. And how the process works is the scanner, it scans the object, and it scans in 3 different dimensions. So when you're taking it, you get your distance to the object, its height, the width, and everything like that. So it's very useful when you're plotting out, when you're using it for plotting out different things during the construction process. And not just, there's usually they take up 50,000 point clouds per second. And these point clouds, in terms of their distance, are very, very accurate, down to 500,000th of an inch. So they're very, very close to the actual distance. And they use these images to put into a CAD system and eventually produce a 3D model.
They're used in construction. I thought this was pretty interesting because throughout the construction process, what you can do is, say this building's being built, you can set up the camera right here when just the steel beams are up, and then shoot that, and then set it up again after they put the drywall on, and shoot that. Then you can overlay them, and over time, you can, like, if you shot it right now, all you'd see is the drywall. Well, you could do it, and you could see all the electrical systems, everything like that that's inside the building. And so it really creates just a complete as-built documents for the entire building,
which is much more accurate than just trying to go out there traditionally, the way they traditionally do surveying. Some of the ways that scanners are used in construction is, like Terry was saying, those 3D models for sites or for as-built structures. They're very, very useful for renovations because it gives you the actual dimensions instead of having to go back to the plans and then using traditional surveying methods to try and find it. You get the exact measurements of the way that the place is built right then and there. And it also serves as a safety measure for when you're doing some heavy civil type stuff, because you can stand away from the site and let it scan. I believe it has up to an 80-meter span. Most lasers do. And then
we have 2 kind of case studies that we've looked at, and they're both in Auburn actually. This one is actually downtown. We talked with Paul Holly. He's a professor, and he actually helped with this project. And after the poisoning of the tumor trees, they figured they're probably going to die. So while they're still alive right now, they would scan them so that over time, maybe 10 years from now, we can get exactly what those trees look like, and not just pictures of them. And whatever the university wants to do, whether they want to do some kind of man-made structure or replant something else, they can get what is most like that. Plus, not only that, you could set it up into some type of interface where people could actually walk through the tumor's corner. Another way that it was used is in the Auburn Arena. When Robbins and Morton built the Auburn Arena, after they capped off and put the roof on, they used these laser scanners, and they set them up, and they scanned the entire inside. And what it did was, in all these stadium seating, they're completely custom built. So it helped with the shop drawings, because instead of just taking measurements of every single seat. They're able to go in there with this system after just one guy, one day, scanning this entire inside. They're able to go in and get exact measurements of the radius, the curves, everything that they need. And so it cut time in way more than half.
Some of the advantages of 3D laser scanners is just like Terry just said, the time saving. It can be as much to 15, 20 times faster than traditional surveying methods. They can have a complete as-built model, which is very, very beneficial because it gives you a whole idea of what the entire thing's going to look like.
And one scan only takes 90 seconds. And so, like when they did the one downtown, it took one person less than one day to just scan those.
And it's just very simple. It has a touch screen on it that you just click 3 or 4 buttons to get it started up, and it just goes ahead and scans it. So it's very, very user-friendly. A couple of the disadvantages and one scan is called a scan world, and what they do when they're creating a full image is they piece these scans together, and that can be a little bit tedious, and you have to know kind of what you're doing with the software in order to do that. Also, it's more expensive than traditional surveying techniques, but we looked into that a little bit more, and when it comes down to it, between the time saving and all of that, it actually turns out to be cheaper in the end. But if you just look on a one item to item basis, it's a little bit more expensive. Another disadvantage is that the files can be very massive. So if you're a small company, most likely you're not going to be able to use this because you won't have the capacity to use these files or to view them with the full resolution.
The most commonly used scanner is made by Trimble. There are a few other scanners. One is made by Leica, but these are just some specifications that we found off of that. It takes 54,000 points per second with the laser. It has an 80-meter range, and so what happens is, say, like when they scanned Tumor's Corner, they were able to take, I believe it was like 5 scans down there and get a complete scan of the entire, like all the way around the trees. The scan is also able to go 360 degrees, and then the field of view like around it is 300. So, and then it also uses each scanner, each company uses its own software.
There are 3 different types of scans. One of them is called a polygon mesh model. And what that is the image here on the left. What it does is it pieces together little square planes and assembles all those planes into an image. So you're not able to go back and edit it. It's the simplest form of a 3D scan. Next type is called a surface model, and it's a little more complex. If you have an entirely smooth surface, and you're able to edit it a little bit when you put it into a computer, but you can only edit the surface of the image. And that's the one here on the second. You see a man's body's getting scanned on the left, and the image is there to the right. It's smooth and it's curved, but you're not going to be able to edit it very much. And then the third type is called a solid CAD model. It's the most complex, and you have an entire representation of what that object looks like. So these are the most high-end scanners, and that's here on the right. You see some pipes right here, and it's a very realistic looking image. And then we have a little video here that kind of gives us another little explanation of how this whole
Quick
process
lesson
works.
from laser scanning to AutoCAD. Beginning in the field, the surveyor chooses each scan position around the object being scanned. The instrument is then set up in the first scan position, and the scanner begins to record. Millions of accurate 3D points are collected in minutes. This process is repeated for each desired scan position around the bank. All scans are then cleaned and connected as a single cloud of points within the scanner manufacturer's software. It can then be brought into AutoCAD for design. For a simple 2D floor plan, a slice is taken from the body of the building. These points are then digitized with traditional AutoCAD commands, and dimensions are recorded as well. What appears to be a 2D plan is actually sitting inside the true-to-scale 3D world of the building. Elevations are similar in nature. Simply set the correct UCS view in CAD and begin digitizing. Although this example has been completed, provides a high-quality template of the as-built conditions. The result is an accurate 2D elevation inside a 3D point cloud. 3D modeling is also achieved through traditional AutoCAD modeling techniques. This is an example of a simple solid model created from the cloud data. In the end, laser scanning gives a user more information in minutes than what could be previously collected in a lifetime. It opens the design world to exciting new possibilities.
So as you can see, this is a very, very useful product with all the little gadgets it gives to you. But that's all we have. Do y'all have any questions about 3D laser scanners?
Any questions?
On that bank project, did they put the scanner outside and inside the bank to get all the detail that they would have had to?
That one they didn't, but you can put the scanner anywhere you want, and as long as you link the points.
And that's what they did was they take those 5 different points that they took and they assemble all of those in the AutoCAD system, and so it connects all those together and gives you the outside dimensions of it. And the lasers, I mean, I don't really know the exact details of how it works, but that's how it does it. Basically, you have a panoramic view of the outside of it, and it assembles those distances to give you your image in there.
So if I understand right, it shoots out a laser, and so it knows the distance and it knows the position of that point, like it's a brick on the side of the building. It knows where that is in space. But how does it get information about the color of the brick and the texture and all that stuff?
It has a camera on the side.
That's
of
the
it,
camera on the side.
and what can happen is it has a bunch of different things that you can do with it. And so what'll happen is as it's going around, it can take pictures, and so they can overlay that camera image with all those points you've taken, and it can kind of piece together.
And basically integrate it into the actual model.
Yeah. But what's happening is it's taken so many points, 54,000 points a second, that because there are so many, I mean, like with a TV, you have so many dots that's just one color, and it becomes a full image that you can see, and it's just the same